So my second talk, embedding AI models into XR projects. So how do you take an XR project and put your own AI into it? We're going to talk about why the heck you want to do this, platform selection. I'm going to do a quick demo, then I'm going to do how to make the demo, and then I'm going into how to make the demo actually useful, because the boilerplate demo that we're provided is not as good as it should be. So again, myself, section supervisor, I've been doing this for a while. Nobody new has come in, so yes, lots of software engineering experience, and I love AI, but my specialty is augmented virtual reality. So motivation. Why the heck do we want to do this? This is the second use case that we're talking about. We want to run a model locally. We may be worried about data security. We might be worried about network connectivity. Maybe we don't have network at all, right? We don't want to go through the cloud infrastructure setup. Even for a developer like me, if I want to get AI in a cloud, then I may have to, I either have to get all the agreements in place, or I might have to spin up a machine and then configure it and download a model and make sure that it runs. Even getting stable diffusion running on an external server takes a few hours. The demo that I'm going to be showing you is going to be a speech-to-text demo. And it was, I would say it probably took me less time to do the first iteration of the speech-to-text than it would have taken for me to do a full cloud integration setup to get servers up and running and to have that server do the speech-to-text for me. So I will say, again, having had some AI development experience, what happens when you're developing an AI, right, is the tools that folks use, they usually have like Docker or Podman or something like that. They have a container, right? So your engineer is sitting there, they have their laptop and they have a container, or maybe they're using Anaconda, but they essentially create a nice configuration bubble so that they can be able to repeat their work. And they go in there and they spin it up, and so they have an environment that is specifically for this job, and then they do this coding or they do the training, and then they have this AI running in this bubble, which is great. It's a fantastic way to work. I absolutely worked that way for years. And what's nice about it, especially with cloud computing and whatnot and clusters, is you can take that bubble and you can upload it to the cloud, and then you can have cloud management software spin up or spin down bubbles as you need, right? So if you're starting getting more requests, you can actually create more bubbles, spin them up dynamically, service those requests, and then spin them down when they're not needed. It's a wonderful way to be able to scale and do things. Unfortunately for us, we can't spin up those bubbles on the headsets, right? You can't install Docker on a Quest 3, right? So there's all of this work, and it's created this nice little container where everything is configured right, and we can't use it for what we're doing, right? That's very much a cloud-oriented type approach. So what the heck do we do? So first of all, we got to think about what is our platform. What are we doing? So we're talking about software platform. Godot, I mentioned earlier, it's a little game engine. It is becoming less of a little game engine and is getting more and more ready for prime time. I'm excited to see that go. Again, big fan of open standards and open source. NVIDIA Omniverse is specifically designed for AI type work. It is really AI focused. Again, it is designed, it provides a little environment on your NVIDIA powered PC, so beware of vendor lock-in here. And that you can work in that environment, and then also if you need to scale up, maybe you're doing a simulation and you want to scale up to a really big simulation, right? It helps you, by working in Omniverse, it helps you scale up to big data centers and having really huge simulations, which is wonderful, again, for AI. Unfortunately, the amount of XR support on that is really limited, right? So for this crowd, it's an interesting tool. It has its uses. But broadly, it's probably not a go-to. Unreal has great XR support. We see it used in all kinds of projects. We see it used in all kinds of games. It's a great engine. Neural network engine is in experimental mode. As much as I do actually, I give Unreal a little bit of grief, but the truth of the matter is I do love Unreal Engine. But if Epic Games tells you it's in experimental mode, you had better believe it's an experimental mode, and you do not necessarily want to be betting the farm on something that's in experimental mode. And then Unity is the game engine that I am most comfortable with, so be aware that there may be some bias there, but it has significant XR packages, and it also has significant AI packages. So for this demo, that is what I chose to use. So I'm going to start with a simple demo.
I feel like the giant mushroom is staring at me. And it's judging me.
So it's a very simple demo, right? I hold down a key, thing shows up, says that I'm recording, I say something, I let go, it shows me what I said, right? And then I do that a second time. Turns out that's important. What's nice about this is the simplicity of the demo. This is the entire user experience that we might want to see. So if we do have a help desk type chatbot or something like that, that's exactly what we want to see, right? Is we would ask it something, and then it maybe has, it shows you what I said, and then maybe it comes up with its own response. But this is, for a speech-to-text system, this is, for a large number of use cases, this is all we really need. What's nice is this is all running locally on the machine. And so I don't need a network connection. This isn't going out anywhere, and it is extremely responsive. There is a transcribing message back to the user to say, hey, I'm transcribing your text, your speech to text. And it happens so fast that we basically don't see it, right? I don't even know if it takes a frame. So I don't even know if it actually gets shown to the user because the transcription is so fast. So how the heck did I do this? So I used a tool called Unity Sentis. So Sentis is a tool set that allows you to run AI models embedded in your apps. So this is something that we're seeing. And again, it has parallels in Unreal's neural network engine. So they're not the only game in town, but this is what I used for this demo. So Onyx, the open neural network exchange format, is a file format that is available so that when somebody trains an AI, no matter the mechanism of the training or the platform of training, that it goes into an open format that you can copy from one machine to another and that you can run from one inference engine to another. What's nice is that Unity's used their compute shaders to be able to read and process the Onyx file format. So the processing is happening on the GPU. It's happening very quickly. So it works on all Unity platforms. So any game or any hardware that Unity supports, they're able to use the compute shaders to be able to run this, which is kind of a big deal. I will say, just because it is binary compatible and could run on your device doesn't mean that you're going to be able to run it on your device, right? A Nintendo Switch is a $400 handheld device, right? A high-end PC will have a $2,000 video card that is just the cost of the video card. That one part is 5 times more powerful than, 5 times the cost of the entire Nintendo Switch. There is a massive performance difference between the two in terms of video memory and compute power and whatnot. So just because it's binary compatible doesn't mean that it's going to go. So that's kind of my caveat there, right? You're not going to run a ChatGPT on a Nintendo Switch. In theory, if you had the ability to convert that into Onyx file standard, it would be binary compatible. But the video memory actually turns out to be one of the biggest limiters. The other thing that's really nice about this, because I talk about performance a lot, having experienced cases where the AI takes up so many resources that it degrades the user experience, is we can break the processing of the AI, called inference, into smaller steps. So normally we talk about frames and frame rate. And so instead of computing all of the input all at once, we're able to kind of pause it and break it into multiple steps so that the frame rate of the device, the user experience, isn't as impacted as much. And again, this is very different than when an AI developer is doing something. Like, they have no reason to slow down the processing of the AI, right? They're usually looking to do the opposite. So in this case with Onyx and the compute shaders, they're able to do the timing such that we still have a good positive user experience. So it's not running as a monolithic task. And what's nice is that there are already examples for things like image recognition, hand pose recognition. And so, really the big question is how the heck do I get a model? Like, I want to do a thing. Like, where do I go? How do I get a model? And there's open repositories that are available out there. You can just go and download some of these. So Microsoft Phi is AI that does things kind of like ChatGPT would. It's more researchy. It's not as full-featured. And this one doesn't also have some of the safety stuff on there. So, big warning, your mileage may vary. Also, it's a 1.3 billion parameter transformer. Again, that's not going to run on a switch, right? You're going to need some really beefy hardware to be able to run that. Now, you also have things like reinforcement learning. Maybe you know some reinforcement learning folks where you have AI agents, right, that are doing things in the world, other non-player characters and whatnot. But again, we've also talked about hand pose, palm detection, eye tracking. These all have an AI component. So maybe you're trying to bring hand tracking to a system that doesn't have it, that has a camera, but it doesn't have built-in hand tracking. This is a way that you can do your own hand tracking on that system. Story creation, right? So you could have dynamic stories written for you, like as on the fly, or music generation. Depth estimation also for the augmented reality crowd. Depth estimation is always a nice thing. So these are some of the neural networks that you can just go and download. So that's the easy mode. And you can do a lot with this, right? Again, the speech to text, I'm using just one that I downloaded. The hard version, you can train the model yourself. So you can go for reinforcement learning. Actually, Unity has also whole sets of libraries on how to do reinforcement learning. Maybe you have a problem like a driving simulator, and you want to have computer-driven, AI-driven opponents, right? And that you can actually train that. You can, through various mechanisms, you can, just have it run and play the game itself, or you can actually demonstrate what good driving looks like, and then it will take that as a starting point and refine its own driving technique from there. I will say this is listed as hard. It is not easy being able to express a problem. This is how, to say this is how you should drive. Turns out that's a real challenge. It's fraught with peril. It is, however, very powerful once you're able to train your own AI agents. Again, one of the other things is, simple problems are simple to train and very affordable, good for education. But when you start getting into real powerful systems, the amount of cost of training them. So anything that deals with computer vision, if you're providing a picture as an input, that training is going to be extremely time and cost intensive unless it's something very simple like MNIST. Because those systems often take hundreds of thousands of dollars to train. And then you start talking about, if you want a really amazing AI, right, you need huge amounts of data and can cost millions of dollars to train. So, when I say train the model yourself, it is a thing that you can do. It's often a worthwhile experience. And doing it on small actors is very approachable and plausible, probably with hardware that you have. But if you think that you're going to create a computer vision-based actor, want to caution you on that. And then, of course, working with an AI expert to help converting existing models over to the ONNX format. So there are models available in open source repositories, or maybe you're working on a project and they're coming up with custom AI, right? So maybe there are AI tools that are you want to be adaptable, or APL has some great stuff going on here in the ISC with AI and making those more accessible. Again, having an interactive experience with those is really the next step, right? So we have some amazing AI engineers doing custom things. So those are the proprietary trained AI systems, but you're going to need some support from that AI team to be able to make that into an ONNX format and understand the input and output parameters to make them ready for game engine use. Okay, so how the heck do we do our mushroom example? So, you go to the website and it says, okay, here's all you got to do, and it's super simple. And it's like you create a new Unity project, you add the packages to it, Unity Sentis, Newtonsoft JSON. You log into Hugging Face, you find the model. So in this case, I used Sentis Whisper Tiny. And then you get the model and the example using Git, so you just clone the code. You're basically just copying the code down to your machine. And then you configure it. You say, hey, use this audio file. Here is the neural network file and the configuration file. And then you say, this is the audio clip that I want to listen to. And you hit go, and it works, which is great. And so the problem is the demo is good, but it's not actually robust, or actually, in a lot of ways, it's not useful, right? So the demos that the AI people, because they're thinking of, in the traditional AI way, you have your thing, you start up, you take an input, you process it, you spit out an output, and then you shut down, right? And then you provide that output, and again, that's the kind of thing that goes in the cloud. That's great as a starting point, but that's not how we work, right? We need to think about that interaction between the individual and the AI services. So at this case, in this demo, it only runs once. You hit the play button, you start the application, it starts up, it takes your audio, it turns it into text, and then that's it. Like, it does that once, and then it's only one set audio file, and it doesn't do anything again, right? You'd have to stop it and start it, and again, it will take that one audio file and process it and doesn't do anything else. So really, we needed to be able to move to something more robust, so we want to be able to record audio, right? And we need to be able to do, we need to trigger the transcription when the recording is complete. We need to be able to run it more than once, right? We want this to be a more interactive system, and we need to be able to tell the operator what's going on. So we had to design something more useful. So in this case, we start with a button press, right? And then when the user presses a button, we provide user feedback, we start the recording. Now, sooner or later, either it's going to time out or they're going to let go of that button. One of those two things is going to happen. You end the recording, and that's where we set the audio clip, right? And we say, hey, this is the audio to transcribe. We begin the transcription, and we give the user feedback. Hey, we've started to transcribe this. And then once the transcription is complete, once again, we provide the user feedback. We show them what we think they said. And then we reinitialize the transcriber. Because again, we're not working in this bubble where we're spinning up and down containers or something like that. So we have to do the reinitialization ourselves. So what did we have to do? So, there was an audio clip. We changed that variable with a method that takes it as a parameter. We write an audio recorder. Turns out in this game engine, it's actually very straightforward. And then once the recording is complete, it sends out that audio clip as a file. We create the reinitialization, and then we set up events that get invoked so that we can go through that workflow and so that the user knows what's going on. So again, these are the specific steps we needed for this demo. The big takeaway, though, is understanding that the AI developers who are working on these things have a different modality. They have a different development philosophy than we do, right? We're constantly in a loop. We're constantly interacting and going back and forth. Whereas a lot of the AI developers, as they go, they get an input, they do a thing, they spit an output, and then they're done, right? So it is going to become incumbent upon us that as we work with these AI systems that we're embedding into our applications, that we have to then add all of the hooks and all of the workflow to turn that into something that is more interactive and useful. All right. So that is, I know, 2 talks really quick. Does anybody have any questions about the second? Okay. All right. So moving forward from here, we're going into a break, and then we're going to be splitting into 2 rooms. James Dean has a couple of talks on Unreal Engine, and it's going to be a shame that I'm going to miss the first one of those because I will be talking on my third topic, which is embedding or which is using ChatGPT to create new behaviors at runtime. So we have those 2 talks going on. So do feel free to take a break, stretch, grab some snacks. If you have any questions, I'm happy to answer them. Otherwise, I will see some of you at, what is it? In 15 minutes? 10, 15? 10:30? Okay. There we go. Thank you. Yeah, so we'll begin at 10:30. So feel free to stretch, chat, meet some of our vendors and folks who are getting set up there. And yeah, so we'll see you 10:30 here for runtime behaviors in AI, and then, or using Unreal Engine in industry at APL. Thank you much.